In this limiting reactant example that says a young painter is using their knowledge of chemistry to develop new paint pigments. In their latest batch of Big Bird yellow paint, they mixed together 21.172 grams of zinc 2 phosphate and 14.291 grams of calcium chromate. Using the following unbalanced chemical equation to complete, you'll note that these are frankly a little weird because you have a 3 here. But let's go ahead and balance this equation. So there is a 3 here, but we also need to put one here, and now we have a balanced equation. So in a limiting reactant problem, we know that we're going to convert reactant to reactant and eventually reactant to product. We are going to use the zinc chromate as our product, and we need to know the masses. So the first thing I'm going to do is calculate the molar masses of all of the important parts, because then all I have to do is do calculations for all of these. So for calcium chromate, it's 156.08 grams. For the zinc 2 phosphate, it's 386.11 grams. That's kind of cramped, so 386.11. And for the zinc chromate, that is 181.04 grams. So now we have the masses. So what we want to do first is identify the limiting reagent. So the limiting reagent can be identified by the one that runs out first. So we're going to convert zinc 2 phosphate and calcium chromate to the other reagent. Now, you could convert reactant to product. The one that makes the least is the limiting reactant. But that won't allow you to answer these two questions easily. And those two questions are really important. So let's get started. So I'm going to take my 21.172 grams of zinc 2 phosphate, and I'm going to convert that to calcium chromate. So there are 386.11 grams and 1 mole. And there is 1 mole for every 3 moles of calcium chromate, and 1 mole of calcium chromate is 156.08 grams. Now this tells me that we need 25.676 grams of calcium chromate. So this is what we need, and this is what we have. This right here tells us that we have a limiting reactant, because if this number was less than what we needed, then less than what we had, the one we started with would be the limiting reactant. But we need more than we have, therefore calcium chromate is our limiting reactant. So this problem can really be broken down into 3 parts. So what is the limiting reactant? And once we have that, we can answer the second parts. So this asks about the excess. This is your theoretical yield, and this is your percent. So if something is the limiting reactant, how many grams remain? None, because we've used all of it. So this is 0.00 grams. Unfortunately, with what we've started with, we cannot determine the excess of the zinc 2 phosphate. So I'm going to convert the 14.291 grams of calcium chromate to zinc phosphate, and the mass of this is 156.08 grams and 1 mole. There are 3 moles for every 1 mole of zinc phosphate, and 1 mole of zinc phosphate is 386.11 grams and 1 mole. And so this gives me 11.784 grams of zinc 2 phosphate. So to determine the excess reagent, we need to subtract what we have minus what we need. So we have 21.172 grams minus what we need, which is 11.784 grams. And this gives me 9.388 grams of the zinc 2-phosphate that remain. So 9.388 grams. And you might be thinking, okay, the starting number had 5 sig figs and the final number only has 4. But with addition and subtraction, it matters how many are after the decimal place. So this should only have 4 because that has the same number after the decimal place. So now we've been able to answer 3 of the 4 boxes. So let's figure out the theoretical yield of zinc chromate. And so to do that, I'm going to take my limiting reactant, calcium chromate, and convert that into the zinc chromate. I'm going to move this up so we have a little bit more space underneath. So I'm going to take my 14.291 grams of calcium chromate. I'm going to divide that by 156.08 grams and 1 mole of calcium chromate. There are 3 moles of calcium chromate, and there are 3 moles of the zinc chromate. And for every 1 mole of zinc chromate, there are 181.04 grams. So this gives us a theoretical yield of 16.583 grams. So 16.583 grams. Now the last one asks, if 13.27 grams of zinc chromate were isolated, what is the percent yield? So the percent yield is what you got divided by what you should have gotten. So 13.27 divided by 16.583. Multiply that by 100, and I get 80.02%. And so this table is going to look quite identical. I am going to update this to say theoretical yield, but this is how we can think about this calculation. So this is a limiting reactant problem, and these are all of the steps that you're going to be expected to take on the exam.